Hello children, a warm welcome to you all. In today's session, you will learn about the important and interesting topic of electricity. Children, you might have seen lightning during rain. How does the lightning appear or be produced? Lightning is an electric discharge between two clouds or between a cloud and the earth. This electric discharge through air appears to us as an electric spark or lightning. Thus, lightning is a live example or evidence for the motion of charge in the atmosphere. Electricity deals with the flow of electric charges through a conductor. Electricity is referred to as a form of energy. The usage of electric current is a very crucial aspect of our life in our day-to-day life. You are already aware of the fact that it is used in houses, educational institutions, hospitals, industries, etc. I am Shubhajit. I am here to explain to you about electric charge, current, and potential difference from the lesson Electricity of Class 10 Physics. Learning outcomes. At the end of this session, you will be able to understand about electric charge, electric current, electric circuit, electric components and symbols, electric potential, potential difference, keywords: charge, electric current, conductor, electric circuit, ammeter, instrument to measure current in a circuit, potential difference, work done, voltmeter, instrument to measure the potential difference in a circuit. Before starting the session, let's look at this concept map. We are familiar with the flow of water through a channel or flow of air from a region of high pressure to a region of low pressure. In a similar manner, the motion of electric charges electrons through a conductor, example copper wire, will constitute an electric current. The electric current passes from the positive terminal, high electric potential of a battery, to the negative terminal, lower electric potential, through a wire. Electric current is often termed as current and it is represented by the symbol I. It is defined as the rate of the flow of charges in a conductor. This means that electric current represents the amount of charges flowing in any cross-section of a conductor, say a metal wire, in a unit time. If a net charge Q passes through any cross-section of a conductor in time t, then the current flowing through the conductor is I equals to Q by T. The SI unit of electric current is ampere, named after the French scientist André-Marie Ampere. The current flowing through a conductor is said to be 1 ampere when a charge of 1 coulomb flows through across any cross-section of a conductor in 1 second. Hence, 1 ampere equals to 1 coulomb by 1 second. Small quantities of current are expressed in milliampere. 1 milliampere equals to 10 to the power of minus 3 ampere. In microampere, 1 microampere is equals to 10 to the power of minus 6 ampere. An instrument called an ammeter measures electric current in a circuit. It is always connected in a series in a circuit through which the current is to be measured. An electric circuit is closed conducting loop or path, which has a network of electric components through which electrons are able to flow. This path is made using electric wires so as to connect an electric appliance to a source of electric charges, battery. A schematic diagram of an electric circuit comprising a battery, an electric bulb and a switch is shown. In this circuit, if the switch is on, the bulb glows. If it is switched off, the bulb does not glow. Therefore, the circuit must be closed in order that the current passes through it. The potential difference required for the flow of charges is provided by the battery. The electrons flow from the negative terminal to the positive terminal of the battery. By convention, the direction of current is taken as the direction of flow of positive charge or opposite to the direction of flow of electrons. Thus, electric current passes in the circuit from the positive terminal to the negative terminal. An electric circuit consists of different components such as battery, a switch and a bulb. All these components can be represented by using certain symbols. It is easier to represent the components of a circuit using their respective symbols. The symbols that are used to represent some commonly used components are summarized in the table given here. You all know about wind and water currents. Charges do not flow in a copper wire by themselves, just as water in a perfectly horizontal tube does not flow. If one end of the tube is connected to a tank of water kept at a high level, such that there is a pressure difference between the two ends of the tube, water flows out of the other end of the tube. Similarly, a difference in electric pressure is called potential difference, is needed for the flow of electric charges in a conductor. This difference of potential may be produced by a battery consisting of one or more electric cells. The chemical action within a cell generates the potential difference across the terminals of the cell, even when no current is drawn from it. When the cell is connected to the conducting circuit element, the potential difference sets the charges in motion in the conductor and produces an electric current. In order to maintain the current in a given electric circuit, the cell has to expend the chemical energy stored in it. We define electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to the other. Potential difference equals to work done divided by charge. For example, suppose you have moved a charge Q from a point A to another point B. Let W be the work done to move the charge from A to B. Then the potential difference between the point A and B is given by potential difference equals to work done divided by charge. Potential difference is also equal to the difference in the electric potential of these 2 points. If VA and VB represent the electric potential at point A and point B respectively, then the potential difference is given by V equals to VA minus VB if VA is more than VB. V equals to VB minus VA if VB is more than VA. The SI unit of electric potential difference is volt, named after Alessandro Volta, an Italian physicist. The potential difference between 2 points is 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to another. One volt equals to 1 joule divided by 1 coulomb. The potential difference is measured using an instrument called the voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. Points to remember: a stream of electrons moving through a conductor constitutes an electric current. Conventionally, the direction of current is taken opposite to the direction of the flow of electrons. Electric current is defined as the rate of flow of charges in a conductor. The SI unit of electric current is ampere. An electric circuit is a network of electrical components which forms a continuous and closed path for an electric current to pass through it. An ammeter is used to measure electric current in a circuit. It is always connected in series in a circuit through which the current is to be measured. The electric potential difference between 2 points is the amount of work done in moving a unit of positive charge from one point to another. The SI unit of electric potential and potential difference is volt, capital V. The potential difference is measured using an instrument called voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured.